And now we're just going over one of the most basic functions in algebra and calculus in general. We're going to be linear functions. So linear functions are typically denoted by the equation y is equal to mx plus b. Let me just write this down. We're breaking down the whole equation. Y is considered the dependent variable. M is going to be considered the slope, which is also equal to the rise over run. And x is going to be the independent variable. And b is going to be considered the y-intercept. So, breaking down with what we have over here. So, if we were to pinpoint a given example, let's just say, for instance, we have an equation over here of y is going to be equal to 2x minus 1. Just to know that here. So, we already know in particular, whenever we break down the following equation, let me just go up. So we notice that we have y, or dependent variable. We have our slope, where it's m, as noted, and m is going to be considered 2. And then we have x as the independent variable. It's just meshed in with 2 over here, and it's just held as a constant. And then meanwhile, the y-intercept, we note, is -1. So b is going to be equal to -1. And then when we break down the following graph that we have over here, let me just zoom in further. We notice that over here, we see these dots. So we have a dot at -1. Let me just erase this part here. And we also have a dot over here. Now, the reason why we have these dots is because, one, this dot here is considered the y-intercept at -1. Then we go up 1, 2. So we have 2 of them over here, and then we go over 1, representing 1 here. And so we're able to determine exactly the nature within our linear function in general, where we have our slope, where 2 is going up, and then we're moving over to 1 on the right, and we see our y-intercept being -1 right here. And overall, between the domain and ranges, the range represents really the y, and the domain represents the x-axis. We notice right here between the domain, it can go as far to the left as possible and to the right, hence infinity as usual. And then range also operates in the same way. And we also need to denote that our slope, m, which is denoted as rise over run, is denoted as y2 minus y1 over x2 minus x1, just as a general formula. Let me just write this out clearer. So we have our slope m is denoted as rise over run, and this is the formula that we rely on for linear equations for our slope. And now let's head over to our first practice problem. And now let's go over our first practice problem. So we need to develop an equation that's going to be going through the points 2 to 3 and 4 to 7. Now, whenever we see this notation, this means that x and y, these are the following points that we see on an x and y axis. 2 and 3 would be, so since we would count 1, 2, and then on the y-axis 1, 2, 3, that point would be located right here. And then 4 and 7, we would go 1, 2, 3, 4, and then we would go all the way up on the y-axis 1, 2, 3, 4, 5, 6, 7. Let's draw the 7 and just move this y-axis over here. So we have 7 here and 4 there. That means that that's going to be located at the intersection between these 2 points. Now what we need to do is that we need to develop a linear equation, where a linear equation, as we all know, is y is equal to mx plus b, where y is going to be the dependent variable, x is the independent variable, m is the slope. In fact, I'll just write this out here. So y is equal to the dependent variable, x is equal to the independent variable, m is the slope, which is equal to rise over run, and then b is going to be the y-intercept. I'm going to introduce a concept for the slope equation. For actually the slope equation, when we mean rise over run, it's typically denoted as y over x, but the slope equation is going to be y2 minus y1 over x2 minus x1. Well, what does that mean? Well, it means namely that whenever we are seeing these two different points that we have to denote exactly which one is going to be further out. So what we mean by that is, so we would have 4 and 7 and 2 and 3 as our points. We already know that 7 is y, 4 is x, 2 is x, 3 is y, and we can also write the equation as we know as 7 minus, looks like 3, over 4 minus 2. Well, we know now that the slope, when we subtract both of them together, are going to be 4 over 2, which it looks like 4 divided by 2 is going to be equal to 2. So our slope is going to be 2. So when we are writing out our equation, we have y is equal to 2x plus b. However, we got to figure out exactly what b is. Well, what can we do? Well, an idea that we can actually do is that we can actually substitute an x and a y. Since we already have an x and a y here, we can do, I'll just do this in another, 3 is equal to 2 over 2 plus b. It looks like 3 is equal to 4 plus b. Minus 4 minus 4. It looks like -1 is equal to b, or b is equal to -1. So once we've already found that, we are actually going to put that in our full equation. Therefore, our whole formula all together, we've already figured out what the slope was as 2. We already plugged this in, and to be able to figure out what the y-intercept is, we plugged in x and y into this, and then our equation is going to be equal to y is equal to 2x minus 1, since we have the -1 here. And that is our answer. Feel free to take a screenshot of this part as well. And let's over to our second practice problem. And so let's consider our second practice problem. Here we have our given equation, y is equal to 3x plus 7. And what we need to do is that we need to plot exactly our linear function. And we know that our linear function, if we wanted to know from numbers all the way to the main equation, we know that it's y is equal to mx plus b, where y is going to be the dependent variable. X is going to be the independent variable. And then m is going to be considered our slope, which is rise over run. And then b is going to be the y-intercept. And so whenever we have our following equation, and we know that y is equal to mx plus b, we can just match up the numbers accordingly. So we know that our y-intercept is going to be 7, so b is going to be equal to 7. And then our slope is going to be, it looks like 3. And our slope is always rise over run. And typically whenever we see a number right here, there's this tiny little fraction down here that is a 1. So we have 3 over 1 is technically our slope, which is typically denoted as 3. And just based on this information alone, we can actually start plotting our linear graph. So we know that we have our x and y axis right here. And if we want to, we can start with the y-intercept. So we can go 1, 2, 3, 4, 5, 6, 7. And we know in a y-intercept, what that means is that it's going to hit at the y-axis over here. So we have a 7. And what does it mean by rise over run? Well, whenever we have our slope right over here, that means I'm going to need to move this up a bit. So just give me 1 second. Just going to move this down just a bit, and I'm going to move this down just a bit. I'm just going to move this as well, because I kind of have to. For the sake of moving. Okay. All right. There we go. So that means... So we can count all the way from 7 at this point to 1, 2, 3. And then we move over 1. So that means on our x-axis, let me just point this out. And it's completely arbitrary. So whenever we have our slope, we do 1, 2, 3, and then 1. So this is where our line is. So we can just plot it this way. And this pattern will continue. So we can go up from this point, another 3 dots, then over 1 as well. So we can go 1, 2, 3, and over 1. This is where the next dot is. And this is how we plot our linear function. Feel free to take a screenshot of this as well. And now let's head over to quadratic functions. But let me just zoom out and clean it up for you folks. Now feel free to take a screenshot of this, and let's head over to quadratic functions. Hey everyone, thank you again for taking time to watch this video. If you found this video helpful, be sure and feel free to please like and subscribe, smash the like button, and ring the bell for any notifications as well. And if you have any other questions, by all means, feel free to put it in the comment section as well. And as always, take care. Cheers. Bye-bye.